In order to tell whether an equation represents direct or inverse variation, we're going to begin by solving the equation for y and then comparing it to our two models for direct and inverse variation, which you see up here. So, for example, if I want to get y by itself in this first equation, I'll divide both sides by x. That leaves me with the equation y equals 7 divided by x. And I can see that that looks very much like the inverse variation equation. So this, in fact, is an inverse variation problem. Now, they may ask you to identify the constant of variation. If they do that, it's very easy to do since there's only one number in these problems. The constant of variation a, what we call it, is just going to be that number. So in this case, the constant of variation is 7. But this is an inverse variation equation. Next up, I want to solve for y, so I'll subtract 3 from both sides, and I end up with y equals x minus 3. Now that doesn't look like either the inverse or the direct variation model, so in fact this shows neither, or neither if you prefer. If there's anything being added or subtracted, it's neither kind of variation, so this doesn't show anything. And last up, while at first glance it may look like another inverse variation problem because of that division, remember you can't make that judgment call until you have y by itself. So in this case, begin by multiplying both sides by 4 to get rid of that divide by 4, and I end up with this equation, y equals 4 times x. That looks like the direct variation model, where it's y equals a number times x. So this shows direct variation. And again, if they do ask you to identify the constant of variation, it's an easy question to answer. There's only one number in the problem, and that would be your constant of variation. So it would be 4 in this case.